So we're going to be working with this motor here, and this is just a test motor. So you could think about this motor as almost like 10 different motors lined up, but because I have this little dial here, it's going to simulate 10 different motors. Some of the motors are good, some of the motors are bad. But let's just go to number 2 for an example, and I want to do a line to ground test. And with this, I can test just regular ohms, or because I have an insulation resistance tester, I can measure the insulation resistance, and I could send up to 1,000 volts DC to pressurize the windings of that motor. Let's get set up to do that test. I'm going to change this dial. So it kind of tells you here it's in orange. So I've got an orange indication here, and I've got an orange. So these 3 things here work together. So I'm going to connect one lead here. My other lead. Generally, you want to use the right angles on your meter here. And then on the other end, typically with your meter, you would have the probe, kind of like this. And you would also have your alligator clamps. So you really want to use your alligator clamps when doing any sort of line-to-line resistance check or a line-to-ground check. Because what can happen sometimes if I'm just using my probe and I'm attaching them with my finger, you know, the resistance of your body sort of interferes with that. So you just want to use your alligator clamps. Let's get ready to do a line-to-ground test. Remember, this meter here, we do know it has a good fuse. We're just going to connect one hot lead to the ground. Now, I could take the ground to the stud, because internally, this green ground wire is connected to any metal component. So I could do that here, but I'm just going to go to the green ground wire. This is an insulation resistance test. It's already set up to send 500 volts, so a DC, of course, right? So I'm going to send 500 volts. I'm going to pressurize the windings with voltage because I want to see if there's any leaks to ground, right? So you pressurize it with voltage. So I'm all set up. I've got my, you can tie these 2 together. If you don't, you want to go back and check the other hot lead. In this case, this is a 2-wire, so I've got 2 hots and then a ground. But I'm just going to show you one here. So I've got my lead set up. Now, I can change this test voltage, so I'm just going to toggle through this to show you. I could send 1,000 volts, 50, 100, 250, 500, right? So let's just use 500 for demonstration here. And so what you got to do is you just got to press, hold, and release. Okay, so that's showing 0 megohms, basically 0, 0, right? So in this case, I don't really need to know the units, but it's 0, right? So that means that you have no resistance between your hot lead and your ground. So that's sort of like saying, hey, they're connected somewhere, right? You have a dead short, which is obviously bad. Okay, so I've done all my tests here. I've checked my fuse. My batteries are good. It would indicate that if you had low batteries, it just wouldn't do the test. It would tell you low batteries. But, you know, I've tested my meter beforehand, and I clearly have a shorted motor. The motor's ground, dead short, right? So let's go back to this meter here, which, again, this has a bad fuse. We've confirmed that because we did the test. I just want to show you what that looks like now. So I'm going to do the same test. I'm going to get it set up for insulation resistance tester. I'm going to send 500 volts. I'm going to connect my leads here. Now, it doesn't necessarily have anything to do with polarity here, but just for consistency, let's just do that. All right, same test, same motor. This has a bad fuse. Okay, it's showing me 550 million ohms, which is a good reading, right? That indicates a brand new motor. It's as good as it gets because the higher the resistance, the better, right? And the other thing that's indicating is this symbol here, see this greater than symbol, means that this meter is maxed out. When you test something, a motor, at 500 volts, that's the largest value that this meter can show you. And again, what does that mean when doing this test? That's a good thing, right? Because bigger is better. And also pay attention to the units, right? 550 meg ohms, meg is a million, so you got 550 million ohms. Getting back to what we talked about, that would be very different if it were 550 ohms, right? Pretty darn close to a dead short. So, I think the key lesson there is meter, I didn't check the fuse, I'm getting a good reading when actually this motor is completely shorted out, right? So always a good idea to test your meter in terms of testing the fuse, testing the batteries, and also testing it on a known voltage source. So if you are going out to measure voltage, let's say to make sure that it's off before you work on your unit, you want to make sure that this meter is working. So you test it on a known source beforehand, then go to the job site, and then also a good idea to test it afterwards. Seems like a lot, but you know, we can clearly see here that with a bad fuse, and this particular meter doesn't tell you it has a bad fuse, right? You have to actually test it. So with a bad fuse, it's going to give you a good reading. So very critical to test your meter, test the voltage, make sure your fuse is good, and batteries. So batteries go quite often. We go through a lot of fuses here. And also leads. These are pretty thin wires, so they get a lot of use here. So always a good idea to have extra fuses, extra batteries, and extra leads themselves. Thanks for watching, and hopefully that was helpful for you. If you want more information, visit our website.